welcome back here at our Capgemini booth. Welcome to the HME, and we will hear now the next session. This will be Shopfloor orchestration with Gen AI. You will learn about what are today's challenges of Shopfloor and how to tackle them in an innovative way. Let me welcome our two speakers. Konstantin Ziesche from Bosch Rexroth as product owner of the asset orchestration platform, and Andreas Hess from Capgemini as chief architect.
Yeah, so thank you. This presentation is about an innovation project we did together with Bosch Rexroth and Google, where we investigated how the asset orchestration platform of Bosch Rexroth could be complemented by a cloud-based service that is leveraging Google's Gemini language model with generative AI approaches. And accordingly, the agenda will look like this. We will start with an introduction of the asset orchestration platform done by Konstantin. I will then explain how our approach from low-code to no-code in process orchestration looks like, followed by a showcase, again, done by Konstantin, and then maybe at the end we have some time for Q&A to look a bit more under the hood how we did it. So thank you very much for your attention. Over to you, Konstantin.
Yeah, let's start with a typical pain point we have in industry. I'll explain a little bit how machine-to-machine interfaces are made today. So maybe some of you know the example. So let me introduce Machine Builder 1. It's Toby. We have another machine builder called Mark. And yeah, they have to align on how to integrate two machines into a production process. So then Toby starts with, we have to name the variable in a certain way. It's say, okay, we want to move this linear axis to a position. When it's done, we should name it like this. And then Mark says, yeah, but usually I would say I start with a Boolean, so move done, I would do it like this. And it continues, yeah, well, what we do, what's about if the process has an error? Yeah? Shall we name it like this or like this? Shall we write it down somehow? And now you see lack of communication. Documentation is often not available. Somebody says, okay, it's not necessary, and then you have a problem. So this is how machine-to-machine interfaces are built today with certain problems. Everybody knows that kind of situation in the industry? Raise your hand if you do. Okay, so, and yeah, what happens next? Yeah, then we have a project manager, it's called David, and a plant manager called Eric. And they said, okay, Eric, everything is fine, the production runs, everything is really perfect, but please do me a favor, do not touch anything, yeah? Because we just made it work. And then Eric says, yeah, well, I have a slight change in the requirements. There's a certain thing we have to change. And then it goes back, and David says, yeah, well, it was not part of the requirement specification, and this is a change, we cannot do that. The SPS or the PLC programmer is not available for the next 2 weeks. We need another one, and it will cost you, and it costs you a lot of money. And that's where we're going at with our solution. So I think this picture everybody understands. You have a maestro in the middle, you have the music notes, this is your script where you perform. The maestro in the middle points to the musicians and tell them when to play what. Our solution does the same, but in an industry perspective. So we have the asset orchestration platform as an application running on ControlXOS. Our script is a so-called BPMN workflow. It's a standard for modeling business processes, but they are executable, consumable by the asset orchestration and its engine to perform a production process. What we also integrate is the so-called asset administration shell. Yeah, it's a standard. You can have a look at the IDTA stand, the Industrial Digital Twin Association. It's a standard for a digital twin where you get all the data, all the information you need from the asset, and also see what skills are able to be triggered from the outside system. And we are not only controlling the machines, we are also controlling other systems. So we are some sort of man in the middle from where we control the machines and also the MES system, ERP system, or any other software solution. And here we have a look how such workflows look like, and we also do a certain change. So this is one of the major benefits of that solution. You can drastically reduce the time for a change in your production process. You just drag something in, add some new element, and deploy it to production. Yeah? So in no time, you can change the entire process. Yeah. And what else can you do? If you execute it, you also see in real time where the process is at. So when you go to the debug tab over there, you see a live monitoring where it is highlighted where you are at the process. If an incident occurs, if something happens, you will see it right away. And again, also here we are using a standard BPMN 2.0 official international IEC standard. Yeah, and this is our offering. We provide the full stack from the PLC programming into up to the integration into the asset orchestration firmware, relying on standards, which gives you 80% faster integration into your software. So if you have a new asset, you integrate it, you build this digital twin, this so-called asset administration shell, and you can also reuse it, and that's why you get this 80% faster integration. And what I mentioned earlier, you can change the process at any time, very easy. You do not need a programmer to change the process, so nobody has to go to the machine and say, okay, I want to change something. You can do it by yourself. A production planner can do that, as well as others in the manufacturing area. So the downtime is there reduced by 60%. Okay. So this is our solution as of now, available on ControlX OS in the ControlX App Store, where you can download it and install it on your system.
Okay, so let's have a look of now what we did during our joint exercise. The status quo is, when it comes now to the question of what skills do I need to apply such a change in an automation workflow, we have a big improvement using that low-code approach. Yeah, so because we now have no longer the need that a production planner needs to intensively work with PLC programming, so we could, at least in the direct collaboration, eliminate the need of PLC programming, because all that technical knowledge, how the assets work, what are their API, how they need to be addressed, is encapsulated in the orchestration platform. And on top of this, you have this graphical model that allows you to describe an automation workflow. So we have a lot of benefits using all that standards compared to the previous situation, but still there's a need that now, if you don't want to introduce another role, yeah, a BPMN modeler, that the production planners need to go to training. Yeah? So learn how to model executable BPMN processes. And this is where our work now started to investigate, hey, can we even improve this, yeah, and reduce that need for deep technical modeling skills with the production planners. We did this in an innovation workshop that we did here in the Bosch Rexroth Innovation Center together with Rexroth, Capgemini, and Google Cloud. And we're addressing here the question, can we minimize the need for these deep modeling skills with the production planners, and what of that part here could be covered by the asset orchestration platform. We did this, maybe not so surprising here in our context, investigating the capabilities of Google's Gemini large language model, and used this entire exercise then under the motto, hey, from low code to no code, yeah, because this is what we wanted to achieve. And to summarize before then do a demo, let's drill down a bit what is in that whole set of skills that you would need, and in particular what capabilities such a language model like Google Gemini can cover and bring in. So yeah, we've expanded this a bit, and to have at the end then an executable process, you first need to start with, hey, what are the assets that are there in my production environment? As said, the platform here is using an standard. So this is something which turned out that the Gemini model understands out of the box. Yeah? So by simply showing these object definitions to the model, the direct reaction without any further prompting was, hey, this is most likely an asset control submodel that could be used in such a process. So you could see, and we are using here the latest model that when it becomes generally available will be Gemini 2.5 Pro, I think will be the name, has seen such definitions already. So next thing is then also an understanding of BPMN processes. Yeah, functionality that Konstantin can show you briefly is explain me the process. Yeah, this is something you can simply prompt and providing an BPMN process here, and you will get an understandable explanation in human language from the model. Next level is create a model from human language, because this is our ultimate target of the exercise, that a production planner can provide such a prompt, yeah, and it is not really required if it is then. You could also say afterwards or that, yeah, and the language will understand your intent and will result in a correct BPMN process. So this is also something that is out of the box and requires only minimal role prompting. A statement like, you are an expert in BPMN programming, this is enough, yeah? So that this can be achieved. This is what I mean by out of the box. What requires prompt engineering is that these processes become also executable on the platform, because here you need to comply with a lot of conventions of the execution engine that is in, yeah, so that you really get executable workflows, and this requires then some level of prompt engineering where you give the guidelines, how this BPMN process really should look like, how error handling is done, how you access the properties of such an asset, yeah, how you invoke the movement operations of the robots that you see there. Yeah, and without further ado, I would say let's go over to the demo and let's look in how it looks like, yeah, when it is really live and in action. Konstantin.
So, I have to show you a video instead of a demo because last minute the internet broke on my machine, so I have no access to the internet, and you can imagine that Google Gemini runs on the cloud, runs in the internet. So I will show it to you in the video. We can later have a look at the stand at the booth over there, where I can show you also that in real life. There we have a better internet connection, not like that. Okay, so let's start with it. So basically, we have two features in that system. One feature is the so-called explainable AI feature. So when we later have a look to the workflows, it's very simple, and you get a lot of transparency and information about what is the process all about. This BPM workflow I was showing you earlier, what do you see in that workflow? This is one feature, and now what we are seeing here now in the video is the second feature, the workflow generation. You're able to just prompt something into this line, and it will generate the entire workflow for it. So we started with an empty workflow, yeah, only with a start and an ending node. And now we add some more, set active shuttle, add active shuttle and move it to position 1000, and it generates this BPMN workflow, which is executable on the asset orchestration platform. It's so easy to do that. Down there you have some couple of examples that you can do, and if we look through it, what we can do, there are endless possibilities. And it's also multi-language. You, of course, can use another language to define the prompt, and it will be especially
and it's phrases like "at the same time," yeah, that you've seen that now causes here this parallel execution. Yeah?
So in here we continue with a lot of things. We have a parallelism that is there. Then we continue, and you can just type it in as you like. and it will always generate the right process.
Yeah. And it's also not super important if you really spell the names of the assets correctly like this. Yeah. So the model will do some assumptions. What is the most likely approach? What is used here? Yeah.
And what is behind? So in the beginning, when we click on the generate button of that solution, it will automatically triggers or queries the registry of the asset orchestration platform where all the asset administration shells are listed, querying the data, querying the required submodels, send it to the service, to the backend service that processes it and enriches the prompt.
Also here, wait for the shuttle to be docked. You have seen, yeah. This is quite rather already a complex thing that you need to do. You need to invoke a task that accesses the property and then is continually looking, hey, has the shuttle already moved to its docking position? Yeah, and then also we say at error handling, yeah, what happens if the shuttle never arrives in its docking position? Typically, this is then in the platform a user task to handle the error, yeah, and fix it in the process.
And what you see here is the entire workflow. You can also do it in one prompt. So if you specify it, you can put a whole phrase into it, and it will generate the entire process.
Yeah, and now you see the movement of the shuttles here in the...
And that's what I was talking about the live monitoring. You see in live, I mean, this is a bit laggy, but you see it there where the process is exactly at and how it runs through that model.
Yeah, so the same way you could do it vice versa, start with something like this and then ask a model, hey, explain me that process, what it is doing, and you get an understandable description in natural language. Okay, yeah, so this is the part that we wanted to show you. As said, you are invited to do it together with us at the stand. But we also do have some time for questions, yeah, if you have some. If not, then maybe I can give you also a few more details going back to this, how it is done. Because creating such a prompt is typically an intensive work, and also this can be supported using GenAI. Yeah? Because the way actually it is done is that we used it using the model. Yeah? So the start of developing that prompt is, I want to do process automation. Yeah? Suggest me a prompt, how it looks like. Yeah? And then typically what such a prompt consists like is the as-is process that you have. It is the asset information that you provide. And it is, of course, the user instructions, how the process the next should look like. So if you start with an empty process, it can be the full description. If you do it in an iterative, incremental way, you could do as well add instructions step by step as we did. Yeah? And this is then together with the details, how to do this, the prompt that is done by the system. And as we are starting with an empty prompt, the next step that you then do is provide an example. Yeah? So, hey, this is the user input, and this is how the output should look like. And then again, ask the model, how should the role prompt look like that converts that input in that output? And based on this understanding of processes and assets, allows you to do also that prompt engineering here in a very interactive way. Yeah, so this also shows quite impressive the capabilities of the Gemini model that is there. So, if there's not really something else, let us invite you here to, on the one side, the Capgemini booth, Station 7, manufacturing right over there. And as well, Konstantin?
Yeah, and there's also in Hall 5, the connected hydraulics demonstrator of Bosch Rexroth on the Fluid 4.0 stand, a publicly funded project, very large publicly funded project. And there we also demonstrate together with a real demonstrator and a virtual one, the same solution, as well also with a GenAI feature.
Thank you for your attention. That's all.
Thank you.